Good morning, everyone, and welcome to this lecture. This is lecture number 3 in photoelectric effect, and we will wind this topic today itself. Just to have a recap of what we had done in the previous class. We were seeing the different graphs that were possible. We had seen the graph of current with the potential difference between the two terminals, cathode and the anode, and we had seen that if the potential is zero, a very small current flows. But if Q is made positive with respect to the cathode is where your light is striking, energy is striking, radiation is striking, the current increases and it reaches a maximum value which is known as the saturation current. If you make the potential negative of Q with respect to P, the current stops. That is known as your that is known as your um, stopping potential. Then just give me a minute. I just need to correct it. Okay, so what I was saying, sharing was, if you make the potential negative at a particular potential, the current stops. Then, if you want to increase the saturation current, you have to increase the intensity of the radiations. When we talk about the intensity of radiation, we are talking about the number of photons which is falling. It can change the saturation current, but it cannot change the stopping potential, because stopping potential depends on the kinetic energy of the electrons, and kinetic energy of the electrons depends on the energy of radiation. The energy of the radiation depends on the frequency of the radiation which is falling, which has to be more than the threshold wavelength. This was the graph of saturation. This was the graph of number of photons, photoelectrons, not photons, varying with kinetic energy. As you can see, not all the photoelectrons are having the maximum kinetic energy. Only some would have it. Do we understand this? In fact, practically speaking, none of them has maximum kinetic energy, because some energy is always lost in some form. Then we had seen what happens if you increase the frequency, the stopping potential increases, it becomes more and more negative. Do we remember this, yes or no?
Yes, sir.
The next graph that we are going to see, and I think we have already seen that graph, is the variation of current with intensity. And as you can see, this graph is a straight line. If you increase intensity, that means more number of photons are falling, there would be more electrons which would be emitted, and therefore there would be more current. Remember, the frequency of the photon must be greater than f naught, or lambda must be less than lambda naught, otherwise nothing happens. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. So we go ahead and we go into the next graph, and these are very important graphs and we are going to discuss them in a lot of detail. The graph is between frequency, as you can see, frequency and kinetic energy, maximum kinetic energy. You can understand that whatever graph is there between frequency and maximum kinetic energy, the same graph will come between frequency and stopping potential, yes or no?
Yes, sir.
So this is the graph between kinetic energy and frequency, or stopping potential and frequency, and you can see the graphs are straight line. Do we understand this?
Yes.
These graphs are inclined at an angle theta, and we will see how you can find out those angles theta and phi and whatever, and what will be the values in the next scene. Right now, just note this. And everybody understands these graphs, yes or no?
Yes, sir.
I'll give you 2 minutes to note it down. Then let us see how these graphs and how we can find out the slope of this graph and what are the equations. These are the two equations that we had seen, and we can understand these equations. We can understand this graph by the Einstein's photoelectric equation. Can anyone tell me what was Einstein's photoelectric equation?
Sir, it is energy equal to W naught plus maximum kinetic energy.
HF is W naught plus KE max. Yes or no?
Yes.
From this equation, you can write KE max. You can write KE max as HF minus omega minus W naught. Yes or no? No, yes.
Yes, sir.
You can write it in this fashion. As soon as you write it in this fashion, this becomes the graph of this one. Yes or no?
Yes, sir.
And the slope of this graph, which is tan of the angle theta, becomes equal to h. Do we understand this?
Yes, sir.
Everyone understands this?
Yes.
Now remember this Ke max is nothing but equal to E into V naught. This E into V naught becomes H F minus omega naught minus W naught. So I can write it as H by E times F minus W naught by E. Everyone understands this?
Yes, sir.
As soon as I write it in this fashion, everyone can understand how the second graph has come. The second graph has come like this. You must remember the intercept of both the graphs. Yes or no? No, yes.
Yes, sir.
Can anyone tell me what is the value of frequency at this point?
W naught by
Anyone can find it out? Frequency here. W naught by F. Do we understand this? Yes or no?
yes.
W naught by H. Do we understand this? You just have to put Ke as 0. Do we understand this?
Yes, sir.
Everyone gets this?
Yes, sir.
Everyone understands this?
Yes, sir.
And how much is W naught? It is H into F naught. So H will get cancelled and we will get the frequency at F naught. Yes or no?
Yes.
Below this frequency, nothing is possible. Do we understand this?
Yes, sir.
Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. And you can note down these important points. Remember, each of these points can appear as question in your exam. Photoelectric effect is an instantaneous process. What do you understand the meaning of instantaneous? Just happens instantly. As soon as a photon falls, the same moment an electron is emitted from the metal if the frequency of the falling photon is more than the work function or the frequency is more than the threshold frequency. Stopping potential does not depend on the distance between the two anode and the cathode. You may feel if the distance is made more, the stopping potential will become less. No, doesn't happen that way. The work function is the energy required to remove electron from the least tightly bound electron. Do you understand this?
Yes,
It
sir.
only depends on the nature of the metal. This is based on conservation of energy. Einstein explained it on the basis of quantum theory. He was given Nobel Prize for this. One photon can eject one electron only. Therefore, the energy of that photon has to be more than the work function. Do we understand this?
Yes.
All photoelectrons do not have same kinetic energy. Their kinetic energy ranges from 0 to maximum. And remember, there will be no photoelectron whose kinetic energy is going to be maximum because some amount of energy will always be lost. Do we understand this?
Yes.
Give you 2 minutes to note this down. Then we move on and just write these 3 points just for the theoretical aspect. They might ask you why this photoelectric effect cannot be explained by wave theory, and why do we need this particle theory, and why did Einstein get a Nobel for this? He explained this on the basis of quantum theory or the particle theory because wave theory cannot explain it. Why does the wave theory fail, or why does the wave theory, or why can't the wave theory explain it? Three problems it has. The first one, all the three problems are as important as the next one. There is no order in which you can write them. Time delay problem. Now, if we take light as a wave, light is coming as a wave and falling on a surface. It has got some intensity. Now, it will take some time for that energy to be distributed on the surface. That would take some time for the electrons to get energy, and that would take some time for this electron to be ejected. That means if light was a wave, this process should have been taking some time, or there must be some time delay between the instant when the energy is falling to the instant where electrons are emitted. But what we have seen is that photoelectric effect is an instantaneous process. This cannot happen if the light or radiations are treated as waves. It can only happen when they are treated as particle. As soon as the particle falls, energy, the electrons are emitted. So that is the first problem. The second problem is the intensity of the problem. According to wave theory of light, if the intensity of light is more energetic electrons should be emitted, because light has more energy, so electrons which are emitted should have more energy. But you can see intensity does not affect the energy of the electrons. It only affects the photoelectric current, how much the current is. It cannot be explained by wave theory, it has to be explained by the particle theory. Similarly, according to wave theory, if the intensity is sufficient, electron should be emitted no matter what the frequency is. But you can see one photon emits one electron. If the energy of that photon is less than the work function, does not happen. Whatever be the intensity, frequency, if it is less than the threshold frequency, emission will not happen. That cannot be explained by wave theory. It can only be explained by particle theory. These are the three problems. Note them down fast so that we can move ahead. Then we move ahead and go on to the last segment. The last segment would be looking at the various formulae that we are going to use, the Einstein's photoelectric equation, and these are the formulae for the Einstein's photoelectric equation, and these are written in all the possible ways, because any of these possible ways you might have to use this formula. The basic formula is, wherever you have this, you will read it as F, okay? And this is F naught. Do we understand this? HF is equal to H F naught plus Ke max. Do we understand this first formula? Do we understand this first formula? We understand this first formula? Okay. Now, in most of the cases, you would be knowing the value of the frequency of the falling radiation, and you will be knowing the work function, or V naught. Then you will be supposed to find out the maximum kinetic energy. So the maximum kinetic energy can be found out using this formula. We understand this? Now, once you see all these formulae, I'll give you 2 minutes, 5 minutes. You have to write them all on your own without looking at the board. So while I'm trying to explain them, you look at the board, try to grasp the formula, and then write them on your own. Now this maximum kinetic energy will be equal to half m into V max square. So you can write this as half m into V max square into h into F minus F naught. From there, you can find out the maximum velocity also. The maximum velocity would be looking like this. Do we understand this? Now, the same formula can be written as, instead of using F and F naught, I can use HC by lambda and HC by lambda naught. Do we understand this? So ultimately, you can write the same formula for V max in this particular fashion. Remember, this is not frequency, this is velocity V, not the frequency. This is the velocity V, can be written in this form. Yes or no? The next set of formulae is for voltage, the stopping potential. The stopping potential V naught. Once you understand one formula, the rest of the formulas are going to come. H into C is 12,375 or 12,400, and lambda has to be used in Armstrong units. Everyone gets this, yes or no? I'll give you 2 minutes to note this down. Well, then, these are the two graphs. We have already seen these graphs, but this is just so that I cover everything that is physically possible for me. These are graphs drawn at three different intensities, I1, I2, and I3. But you can see the frequency F is fixed. Do we understand this?
Yes.
What would be the relation between I1, I2, and I3?
I3 will be greater and I1 will be less.
This is the graph drawn at the same intensity but three different frequency F1, F2, and F3. What will be the relation between F1, F2, and F3?
F3 will be greater and F1 will be less.
Draw the graph. I'll give you 1 minute. Then this is the first problem, and I hope that you can solve this. The work function of a metal of a substance is given as 4 electron volt. The longest wavelength of light that can cause photoelectric emission is how much? And the answer is option C. How do you get this answer, my dear friends?
Uh, H, HF not equal to 4 electron volts.
The longest wavelength. If we talk about the work function W naught, work function W naught can be written as HF naught. It can be also written as HC by lambda naught. From this, you can find out the value of lambda naught, which is the longest wavelength that can emit radiations. And I've always told you that this can be written in short as 12,400 divided by lambda. You have to find out lambda naught. So this is lambda naught. That must be equal to 4 electron volts. You can multiply, divide, and you will end up with the answer. And I think the answer that you are going to get would be 310 nanometers. Yes or no?
Yes.
3100 Armstrong unit, which will be equal to 310 nanometers. Yes or no?
Yes.
Everyone understands this?
Yes, sir.
The more the number of questions you do, the better you are going to be. And this is the next one. Photo energy, photons of energy. 6 electron volts are incident on a surface of work function 6 point, no sorry, 2.1 electron volt. What is the stopping potential? I'll give you 2 minutes to do it.
answer option B.
Anyone with any answer, or shall I do it?
Option D, sir.
Option D. No. How did you get option D? Give you 1 more minute. Okay, I think I'll have to do it. So how are we supposed to do this? How did you do it? How did you get 8 lambda or whatever?
Sir,
Yes,
HA
beta?
by lambda equal to HA by lambda naught minus 4.8 is the first equation.
The value of V naught. We have already seen the formula HC by E into 1 by lambda minus 1 by lambda naught. Yes or no? No or yes?
Yes.
That's it. Nothing else, my dear friends. In first case, stopping potential is 4.8. That should be equal to HC by E into 1 by lambda minus 1 by lambda naught. In second case, it becomes 1.6 HC by E 1 by lambda dash minus 1 by lambda naught. This lambda dash, what is the value of this lambda dash?
2 lambda.
2 lambda. From here, you have to calculate the value of lambda naught. Probably this is not the time and the place to tell you how to do this. How will you do this? Well, I will leave that to you.
Divide.
You are intelligent enough to solve this. Just divide the two equations and you will land up with your answers. And I'm again afraid to say that your answers, your calculations, only God can help you with your calculations, because if you physics can only take you up till here. After that, it's just your calculations. Your calculations are really not good enough. 4 lambda is the answer, option P, and I'll not go into the technicalities of that. We'll move on to the next question. And the next question is from your this session only. And this is the question from this session. This is 1st February, session 2, shift 2. And this is the question. For a photoelectric setup, The threshold frequency is F naught. Incident frequency of 2F naught. Stopping potential is V1. For a frequency of 5 times F naught, the stopping potential is V2. Find the value of V1 by V2. Option D, 1 by 4. Okay, I don't have the answers for this, but anyways, I can solve it. So I know that the stopping potential V naught is HC. Here frequency is given, so I don't have to even write HC. It will be equal to H into F minus F naught. In the first case, my dear friends, V1 is H into 2F naught minus F naught. In the second case, V2, it is H 4 times, 5 times F naught minus F naught. It cannot get simpler than this. And thank God this time the calculation is right. And the answer seems like it is 1 by 4. So congratulations everyone. We have ended up with a right answer. Thanks Almighty for that. Almighty has helped us in our calculations. And I hope that Almighty keeps that same blessing on us that we are able to calculate the values correctly. I saw a question. I'm not able to get that question. Where is that question? I saw a similar question. Where has that question gone? It was here, previous year paper. Where that question has gone? Where that question has gone? It's here. No, this not this one. Anyways, I'll look into it. Meanwhile, you can. Okay, this will be. Let me give you this one. Till then, I will find out that question and give it to you. This is the next question, a filling question. The lowest frequency of light that will cause the emission of photoelectrons from a surface of a metal. The work function is 1.65 electron volt will be. Do it fast. Option C is the correct answer. Congratulations. So basically, if you look at this question, the only thing you had to calculate, because all the options were same, you just had to calculate the power correctly. Yes or no?
Yes.
Now, remember, every question that you are going to get, and I've told you that many times, in JEE these days, it's a test of your speed, nothing else. How quickly you can get to the answer. Now, obviously, to get the value of this one, if I just use this formula, which one? The lowest frequency, the work function is given. So HF naught is given as is W naught, and it is given as 1.65 into 10 raised to the power. Oh, sorry. 1.65 electron volt, and 1 electron volt is 1.6 into 10 raised to the power minus 19. So to get the value of F naught, you have to divide 1.65 into 1.6 into 10 raised to the power 19. You have to divide it by 6.6 into 10 raised to the power minus 34. Did you do it this way?
Yes.
See, You could have done it in another way as well. Now this work function W naught can be written as H C by lambda naught. Yes or no?
Yes.
So you could have found out lambda naught by dividing 12,375. This was given as 1.65 because when you divide 12,375 by 1.65, the answer is a very sweet 7,500 Armstrong unit. Now, once you get the answer as 7,500 Armstrong unit, you can find out the value of F naught as C divided by lambda naught, which is now very simple because 3 into 10 raised to the power 8 divided by 7,500 into 10 raised to the power minus 10 is pretty straightforward. Now, no matter how you do it, you have to get to the answer faster with the correct values. In this case, the answer is 4 into 10 raised to the power, not 11, but 14, I think. Sorry, I made the wrong option. 10 raised to the power 14 hertz. Do we understand this?
Yes.
So just remember this. And here comes the question that I was looking at. I found it out. This is a question from 2022 JEE. 2022 JEE, and that might remind you of what we already have seen. So remember, beta, these are the type of questions that are coming these days. The more you practice, the more is the probability that a similar question, even the same question with even the same values, may appear in your exam. Same values even. 2022. 4 is the answer. Again, the same principle. V naught is HC by E into 1 by lambda minus 1 by lambda naught. In first case, V naught is 3 V naught HC by E 1 by lambda minus 1 by lambda naught. In the second case, V naught becomes V naught HC by E into 1 by 2 lambda minus 1 by lambda naught. From here, you have to calculate the value of lambda naught. And I think the value that I am getting is 4 times lambda. If this is the answer that you are getting, then well done. Do we understand this?
Yes, sir.
What, sir? And as you can see, I had no idea. I did the same question, almost do the same question every year. I had no idea. I just now saw this question appeared in the JEE of 2022. And I did the same question in the class. Every class I do it. So I keep on telling you always, if you just do the questions in the class that are good enough for you to clear any exam. When radiation of wavelength lambda is incident on a metallic surface, the stopping potential of the radiated photoelectrons is 4.8 volt. Does this question remind you of something?
Yes, sir.
What is the answer?
Option 2.
So if you do questions hard enough, you might end up with the same question appearing for you. Looking for another question. Meanwhile, I'll give you the next question which I have in my sheet. I'll have to mark these questions so that I know I've not marked this sheet for a long time. I need to mark it. I'll do it now. This is the next question. Light of two different frequencies whose photon have energy 1 and 2.5 electron volt respectively successively eliminate a metal of work function 0.5 electron volt. This may be the type of question, maybe the same question, and come in your next session. Find the ratio of Ke max. So how are we supposed to do this? I think it is pretty simple. The maximum kinetic energy Ke max can be written as E minus the work function, yes or no?
Yes.
So the ratio of Ke max 1, Ke1 by Ke2 can be simply written as 1 minus 0.5 divided by 1, 2.5 minus 0.5. Yes or no?
Yes.
Once you understand this, I think the ratio will come straight away as 1:4. Everyone gets this? Yes or no? No, yes.
Yes.
Do we understand this?
Yes.
Okay. Then I give you this question. Remember, I'm just trying to get rid of these 2022 paper. So this is again a question from 2022 paper. In a photoelectric experiment, increasing the intensity of incident light, which is the correct option from here? Yes, my dear friends.
Option 4.
Option 4, you are changing the intensity. That means you are changing the number of photons which are incident. That will increase the current, but it will not have any effect. Any effect on what?
Kinetic energy.
On the kinetic energy. Next one, this one again from the paper of 2022. Two identical photocell photocathode receives the light of frequency f1 and f2. If the velocities of the photoelectrons coming out are v1 and v2, what is the relation? I'll give you 2 minutes. Option 1 is the correct answer. Everyone got this? Yes or no? No, yes. Huh?
Yes, sir.
Half mv max square will be equal to h into f minus f naught. Yes or no? You
Yes.
just need to eliminate f naught from this equation. Do we understand this?
Yes.
Everyone understands this.
Yes, sir.
These are the questions specifically from JEE of 2022. See, this one, the stopping potential in the context of photoelectric current depends on the following
Option
property.
4.
Option 4, frequency. I hope you understand this. Yes or no? No, yes.
Yes.
This is the next one in line again from 2022. The stopping potential for electrons emitted from a photosensitive surface illuminated by light of wavelength 491 nanometer is 0.710. When the incident wavelength is changed to a new value, the stopping potential is 1.43. Find the new wavelength. Well, how are we supposed to do this? So, the only equation that you can use is hc by lambda will be equal to work function phi plus E into V naught. Yes or no?
Yes.
In first case, my dear friend, SC by lambda, you can write it as 12,375 or 12,400 or 1240 in nanometers, because answer is given in nanometers, divided by the value is 491. That will be equal to 5 plus E times V naught. So just multiply it by it and you can write it in the form of 0.710. That is the first equation. In the second equation, it will be 1240 divided by lambda will be equal to 5 plus 1.43. From here, you have to calculate the value of lambda, and the answer that I have is 382. So that is the answer. Your answer is definitely not correct. Anyways, I won't comment on this. I will have to move forward in life. And we move on to the next question. And the next question is here. And it is like this. Photoelectric emission is observed from a metallic surface of frequency f1 and f2 of the incident light rays. f1 is more than f2. The maximum values of kinetic energies are in the ratio 1:k. What is the threshold frequency? Option B is correct. So which formula you have to use here? Ke max is H into F minus F naught. In first case, if I call it as Ke 1, that will be equal to H into F1 minus F naught. In second case, Ke2 will be H into F2 minus F naught. You just divide 1 by K will be equal to F1 minus F naught divided by F2 minus F naught. From here, you should be able to calculate the value of F naught. And I think the answer that you are going to get is K times F1 minus F2 divided by K minus 1. That is the answer. I hope everyone is able to understand this. Yes or no? No, yes.
Yes.
The more the number of questions that you are going to do, the better you are going to become in this particular topic. This is the next one, and I give you 2 minutes to solve it. Light of frequency something is incident on a substance of photoelectric work function 6.125. What is the maximum kinetic energy? And the answer is option C. How are we supposed to get this? You have to find the kinetic energy. Oops. Ke max will be equal to H into F minus the work function. You just put the values and get the answer. Do we understand this?
Yes.
And the answer that you are going to get is 27 electron volt. Well done. Shall we move ahead to the next question?
Yes.
This is the next one. A photocell is receiving light from a source placed at a distance of 1 meter. If the same source is to be placed at a distance of 2 meters, then the ejected electron, I'll give you 2 minutes to do this. How did you get option G? Yes.
Intensity is power by area.
Intensity is power by area. Okay. So,
Sir, number of photoelectrons is directly proportional to intensity. So they are
yeah.
inversely proportional to 1 by r square.
Number of photons which will be hitting is directly proportional to the intensity. Number of photons which will be hitting will be proportional to the number of electrons, and this intensity is inversely proportional to the distance square. If you make the distance twice, the intensity will become 1 by 4, the number of photon will become 1 by 4, the number of electrons which would be emitted will become 1 by 4, and therefore the electric current, the photoelectric current will become 1 by 4. Do we understand this?
Yes.
This is the next one. When yellow light is incident on a surface, no electrons are emitted, while green light can emit. If red light is incident on the surface, then what happens? Option A. How did you get the answer as option A?
Sir,
Now,
the red light.
remember this VIBGYOR. Yes,
Red light has more wavelength.
red light has more wavelength. When yellow light is incident, no electrons are emitted, while green light can emit. If red light is incident, then what will happen? Red light will have more wavelength. The threshold wavelength is yellow light. You are making more wavelength to fall onto it. Will it be able to emit any electrons?
No, sir.
And the answer is no. Option A. Do we understand this?
Yes, sir.
This is the next one. When a metal surface is illuminated by light of wavelength 400 and 250 nanometers, the maximum velocities are v and 2v. The work function of the metal is how much? So, how are we supposed to do this? We have to find out the work function of the metal. So, in first case, half mv square is hc by 400 plus the work function w naught. In the second case, it is half m into 2v square. 2v square is 4v square. That will be equal to hc by 250 plus the work function. From here, you will have to eliminate v. How are you going to eliminate v? Just you can divide this and you will be able to eliminate v from here, and you should be able to get the answer for work function. And I'm very sorry to say that the answer that I have with me is 2hc into 10 raised to the power 6, which should be correct. So the answer that you gave me is wrong, and I can't justify the reason why the answer was wrong. So I will leave it at this, and we'll move on to the next question. And the next question is, anyone has noted this down?
Yes.
And the next question is this. This is a question taken from 24th of Jan, shift 1. And I'll give you 2 minutes to give me the answer for this one. I hope this question, since it does not involve any calculations, I hope that I can get a correct answer for this one. I'll
Option
give you
D.
2. Yes?
Option D.
Option?
D.
Option D. Okay, well done. It cannot be explained by the wave theory of light. Where does this wave theory fail?
Frequency, time delay, and intensity.
Frequency, there is a problem for frequency, there is a problem of time delay, and there is a problem of intensity. These are the three problems, and because of these three problems, wave theory cannot explain, and we have to, Einstein had to propose this quantum theory, particle theory, to explain what is happening. Everyone understands this? Yes or no? No or yes?
Yes, sir.
That takes us to the next question. This is the next question. The work function of metal A and B are in the ratio 1:2. If light of frequency f and 2f are incident on surfaces A and B, the ratio of maximum kinetic energy f is greater than the threshold frequency of A, 2f is greater than the threshold frequency of B. 1:2 is the answer, my dear friends. Work function are in the ratio. You have to find the ratio of maximum kinetic energy. So maximum kinetic energy Ke max is equal to Hf minus the work function. Yes or no?
Yes.
Oh, why I'm writing the work function? So I can write Ke1 by Ke2 will be equal to Hf minus omega naught divided by H into 2f minus 2 times omega naught. Yes or no?
Yes, sir.
So from there, I think you are going to get the ratio as 1:2. Everyone guess this? Yes or no?
Yes.
This is the next question. A point source of monochromatic light is at a distance of 0.2 meters from a photoelectric cell. The cutoff voltage and saturation currents are this. The same source is placed 0.6 meter away. What will be the value? Yes, which one?
Option B, sir.
Option B. The stopping potential would be 0.6 electron volts. Why do you think the option would be B?
It is independent of the distance and frequency, sir.
Yes, the frequency of the source is same. So whatever be the energy of the photon will remain same. What is going to happen is the number of photons which are falling are going to become 1 by 9. Yes or no?
Yes.
So the current will become 1 by 9 times. So current will become 2 milliamps, but the stopping potential will remain same. Everyone is able to understand this?
Yes.
Same question, exactly same question may appear in your paper. So please be very careful. This is the next one. In a photoemissive cell with excitation wavelength lambda, the fastest electron is V. If the exciting wavelength is made 3V by 4, 3 lambda by 4, what is the speed of the fastest moving electron? It is made less. I'll give you 2 minutes to solve this. Now this question is more a question of maths rather than a question of physics. Now we remember that Vmax. What was the formula of Vmax? Can anyone remind me?
Root over
Root over
2hc by m minus 1 by lambda minus 1 by lambda naught.
2hc by m into 1 by lambda minus 1 by lambda naught. Yes or no?
Yes.
So Here what is happening is, I mean, instead of getting into roots and all that, you can just write V max square is proportional to 1 by lambda minus 1 by lambda naught. Yes or no?
Yes.
Now, so V2 by V1 squared will be equal to 1 by 3 lambda by 4 minus 1 by lambda naught divided by, oh, I'm doing it, no, correct, divided by 1 by lambda minus 1 by lambda naught. Yes or no?
Yes.
Now, so V2 by V1, this is more a question of maths rather than a question of physics. V2 by V1 will be root over 4 by 3 lambda minus 1 by lambda naught divided by 1 by lambda minus 1 by lambda naught. Yes or no?
Yes.
Now, once you get this, using a bit of logic and bit of maths, you have to tell me which is the correct option. Which is the correct option? Will V2 be more or V1 be more? You have to look at this value and you have to see whether this value will be more than 4 by 3 or less than 4 by 3. Do we understand this?
Yes.
Will it be less than 4 by 3 or will it be greater than 4 by 3? That is all maths that you have to understand. This value is going to come more than 4 by 3 and therefore the answer is this one. Do we understand this? And this has got nothing to do with physics. It has got everything to do with maths. Do we understand this?
Yes, sir.
Everyone gets this?
Yes, sir.
I hope you have understood this. This is one of the difficult problems because it has maths and so much maths is not coming these days. So I'll leave it at that. This is the next problem that comes. Two photons, each of energy 2.5 electron volt, are simultaneously incident on a metal surface. Then from the surface of the metal, what will happen?
Not even a single electron will be emitted.
Not even a single electron will be ejected. You must understand that one photon emits one electron. If you incident two photons and the energy of those two photons is more than the more than the threshold, more than the work function, that does not mean that two photons would be able to eject one electron. This is just to make you understand and remember that one photon emits one electron. That is why this thing can only be explained by the concept of the particle theory of light. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
This is the next one. I'm trying to cover all types of question that has the potential of coming. This is the next one. When light of wavelength lambda is incident on a metal surface, stopping potential is found to be x. When light of n lambda, the stopping potential is found to be x upon n plus 1. Find the threshold wavelength. Yes, beta, what is the answer?
Lambda by n square plus n plus 1.
Lambda by n square into n plus 1. That I'm afraid is not the answer. I'll still give you 2 more minutes to solve it. There's only one equation you have to use, my dear friends. We have done so many questions on the same equation. You just have to eliminate something from the two equations and get the answer. You are not able to do it. That means something is wrong with the calculation aspect. I don't understand why you're not able to get the answer. In first case, the stopping potential is x. So E times x will be equal to hc by lambda minus hc by lambda naught. In second case, E times x upon n plus 1 will be equal to hc by n. The wavelength has become n times lambda hc by n lambda minus hc by lambda naught. You will have to divide both of these, bacha. Eliminate lambda naught from here. That is what you got to do. I just can't tell you how to do this. I'm very disappointed that you got the answer. The answer that I have is n square lambda. I can't help you in solving it. That is the answer. Please note it down if this question comes. You already know the answer at the back of your hand. Anyways, this is the next question. The surface of a metal of work function phi is illuminated by a light whose electric field varies with time. Wow. Find the maximum kinetic energy. Remember, whenever this question comes, now if this question would have been this, let me break this question into this. This electric field is given by E naught cos omega t. If the question was like this, it is placed in a electromagnetic radiation E is equal to E naught cos omega t. What will be the maximum kinetic energy of the photoelectrons emitted? If this was the question, then what would have been your answer? Do you understand the question?
Yes.
If this was the question, this electric field was given by E is equal to E naught cos omega t, then what have been your answer? Well, so difficult to give the answer in this case. Well, my dear friends, kinetic energy maximum in this case would be H into F. Frequency omega is given, my dear friends. From omega, you should be able to calculate the frequency. I hope so. Frequency is omega divided by 2 pi, my dear friends. So the answer would have been H into omega divided by 2 pi minus phi. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Was it so difficult that you could not even utter something, anything? Must have been. Anyways, this was the answer if the electric field was given as this. Now, here the electric field is given in the form, this is basically a question of maths and not a question of physics, and I can understand that whenever maths comes, we are all at sea. I can write this electric field as E is equal to E naught sine omega t plus E naught cos omega t sine omega t. So basically, this electric field consists of one field which has a angular frequency of omega. Do we understand this?
Yes, sir.
And you have something which is cos omega t multiplied by sine omega t. Can you convert this cos omega t multiplied by sine omega t
Sir,
into sum?
sir, it actually is omega naught.
Yeah, beta?
It is omega naught, sir, not omega.
Doesn't matter. Do we understand this?
Yes.
Oh, one is omega and one is omega naught. Okay, okay. One is omega and one is omega naught. Do we understand this?
Yes, sir.
One is omega and one is omega naught. So cos omega t multiplied by sine omega naught t, this is multiplication. Can you convert this into addition? Do we understand what I said? No? Okay. If you're not understood, there is no point of waiting. E is equal to E naught sine omega naught t, and I can write this as plus E naught by 2 sine of omega naught plus omega t plus sine of omega naught minus omega t. Do we understand how this is done?
Yes, sir.
What I have done here? Can you tell me what I have done here?
Sine of a plus b and like sine of a minus b.
I have converted the product. I have converted the product of two trigonometric ratios into the sum of two trigonometric ratios. Conversion of product into sum, that is what I have done. Now if I look at it, what do I see? Here in this first case, I only had this electric field only consists of one electric field which was having the frequency, the angular frequency of omega. What do I see here in this one? What do I see here in this wave?
It has two frequencies.
Take deep breaths. Close your eyes for a moment. And open them slowly. Look at the board and then tell me, what do you see? Calmly. Yes, what do we see? In the green one, I see a wave which consists of only one wave which has an angular frequency of omega. What do I see in the next one? Right hand corner, right hand column. Yes. Okay, we don't seem to understand it. I see a combination of three different waves. The first wave is sine omega naught t, which has the frequency of omega naught. The second wave which I see is the wave E naught sine omega naught plus omega t. The frequency of this wave is omega naught plus omega. I also see, my dear friends, the third wave, which is E naught sine omega minus omega naught minus omega t. The frequency, the angular frequency of this wave is omega naught minus omega. So this is a combination of three different waves with three different frequencies. Three different waves with three different frequencies. Three different waves with three different frequencies. Do we understand this?
Yes.
On what factor does the kinetic energy of the particle, the maximum kinetic energy, depends on? The maximum kinetic energy of the photoelectrons which are emitted, it depends on what factor?
Frequency, sir.
It depends on frequency. Now I have a wave which consists of three different frequency, a combination of three different frequency. Which wave will give me the maximum kinetic energy of the electrons which are emitted?
Second wave.
Second wave. That is the answer, my dear friends. The maximum kinetic energy of the photoelectrons which will be emitted by this wave will be given by nothing but h into omega plus omega naught divided by 2 pi minus 5. Whenever a question comes, my dear friends, where you have a wave which is given in this form, what you do is, this may not be the question that comes here, this may be a question that comes in the chapter on wave. You convert this product function into some function and then you see it as a combination of two different waves. Do we understand this?
Yes, sir.
This is the answer for this one. I'll give you 2 minutes to note this down. If you have any doubts, please ask. Then we move on to this part where we try to solve the remaining questions that can come from this particular part. De Broglie wavelength. And this is a question from JEE Main of 2022. The de Broglie wavelength for a proton and alpha particle are equal. What is the ratio of their velocities? One by 4 is, I'm afraid, the wrong answer, my dear friends.
4:1, sir.
I have no words to explain what you are doing. I better not explain them because this is of no use. Lambda is h divided by mv. So we have done 1500 questions on this, but still you're not able to get the correct answer. Must be a fault somewhere. I don't know where. Now lambda is same, so mass of the proton into the velocity of proton will be equal to mass of the alpha particle into velocity of the alpha particle. The ratio of their velocity, that means you have to find out Vp by V alpha, my dear friends. That will be equal to M alpha divided by MP. I don't know from where you are getting 1:4. The answer is 4:1, my dear friends. That is the answer that you should have got, but as I don't expect any one of you to do simple calculations like this correctly, so no harm done. This was a very tough question because it has the ratio. You have to find out the ratio. Trust me, this is the most difficult thing for me to find out the ratios, and as I can see, it is also very difficult for you to find out the ratios. Anyways, takes me to the next question, again from the same paper. Same paper, when I say that means the paper of 2022. And this is the question: an alpha particle and a proton are excited from the rest by a potential difference of 200 volt. After this, the de Broglie wavelength are alpha, lambda alpha, and lambda p. What is the ratio? So how are we supposed to do this, my dear friends? Yes? H upon mv. Yes or no? Now, if you remember, you can also write it as H upon under root 2 mqv. Do we remember this?
Yes.
That means you can say that lambda is inversely proportional to 1 by root over m into q, because v is same here. Yes or no?
Yes, sir.
Well, that is what you had to do. So lambda proton divided by lambda alpha will be equal to under root of m alpha into charge of alpha divided by m of proton into charge of the proton. Yes or no?
Yes, sir.
So how much will this come?
8, sir.
It will come as 2 root 2, my dear friends, not 8. There is also a root there. 2 root 2 it will come, my dear friends. The answer will be 2.8. I'll give you 1 minute to note this down. You're making the same mistakes, beta, every time. Your calculations are out of this world. That is going to be the biggest challenge for you, and your time is running out fast. Your calculations are not getting any better. I must tell you that. Please be careful about that. This is the next one. An electron of mass Me and a proton of mass Mp, which is 1836 times the mass of an electron, are moving with the same speed. Again, from the year of 2022, I'll give you 2 minutes to give me the answer. So again, you must know that lambda, the de Broglie wavelength, is h divided by mv. Here the speeds are same, so I can write lambda for electron divided by lambda for proton will be mass of proton divided by mass of electron, and the ratio is given. So the answer that we are going to get would be simply equal to 1836. These are the questions that are coming these days, beta. As you can see, the questions are pretty simple and pretty straightforward. If you just remember simple things, you should be able to solve the questions. The next one again from the year 2022. Two stream of photons possessing energy is equal to twice and 10 times the work function of a metal are incident on a metallic surface respectively. The ratio of maximum velocities of electrons emitted in the two cases is x is to y. What is the value of x, y, whatever? One by 3 is the correct answer. Congratulations if you got that answer. How did you get that answer? Remember, V max square will be equal to, sorry, I'm writing V max square, so it will be 2hc by m into, let me write it like this. It is given in terms of work function, so let me write it as this. Let me write it in this form. E minus 5 multiplied by 2 divided by m. That would be the better way of writing it. Yes or no?
Yes, sir.
Rest is everything is constant, so I can write V1 by V2 will be equal to under root of E1 minus phi divided by E2 minus phi. Yes or no? Yes or no?
Yes, sir.
This first energy is given as 2 times phi, the second energy is given as 10 times phi. You can see they are going to always give you the values in such a way that the calculations are going to be pretty damn simple. But even this simple calculation, if you make a mistake, my dear friend, there is no looking back. Do we understand this?
Yes, sir.
Now let us quickly solve all these questions that have come in your previous year. I mean, this year only, different shifts. And this is the first one. This is 2010, 23, 25, 25th of Jan, morning shift. Find the de Broglie wavelength when a charge is accelerated to a potential difference of 2 volt if it was lambda naught when the charge was accelerated by a potential difference of V. I'll give you a minute. A minute. So we must remember that this lambda is h divided by under root of 2m into q into v. Yes or no?
Yes, sir.
So I can write lambda 2 by lambda 1 will be under root of v1 by v2. Yes or no?
Yes, sir.
So v1 is v divided by, no, yes, v1 is v divided by 2v, and my dear friend, again you have made the same mistake finding out the wrong option. The right option is lambda naught by root 2, so you get minus 5. And whose mistake is this? I don't know whose mistake is that. Anyways, may God help you. That is the only thing I can now expect from you, because only God can help you now, as you are not ready to help yourself. Your calculations and your ratios are awful. Very sad to say that. It does not improve. It does not improve. Anyways, I'll have to move ahead in life. This is 1st Feb. 1st of Feb, 27 days before. Shift 1. The de Broglie wavelength of a proton and alpha particle are same. The velocity of proton is c by 10. What is the ratio of kinetic energies? You have 2 minutes, and I know that you are not going to give me the right answer, but still I can hope against hope that right answer will come someday, because God exists. So the de Broglie wavelengths are same, when that means that m into v, the momentum is constant. So now I can write mass of the proton multiplied by the velocity of the proton will be equal to mass of the alpha particle multiplied by the velocity of the alpha particle. From here I can get the velocity of the alpha particle will be c by 40. I have to find out the ratio of their kinetic energies. I am very weak in ratios, but I am still stronger than you guys. Kinetic energy of proton divided by kinetic energy of the alpha particle will be equal to half. Mass of the proton is m. The speed of the proton, let me call it as v square. Then the mass of the alpha particle is 4 times m. I don't need to find out the c by 40. It is 4 times, sorry, not 4 times c. I'm weak with ratios. It is 1 by 4 times, so I can write it as v by 4 squared. That should give me the ratio half. Don't worry about them. They are going to go bye bye. Bye bye. 4 square. 4 will go in the top. And the answer that you should get is 4:1. And that is the answer. Do we understand this? All the questions that are going to come from this chapter will be on this template, if I call it. Either this one or this one. One more thing is left, which is X-rays, which we will deal in the next class, that is tomorrow, and we'll be winding out this part of the curriculum. Have you understood what we have done today?
Yes.
You can see Whatever year I take questions, they are on similar lines, similar grade, similar template. You just have to be careful of what you are doing, which ratio you are finding. I think you would be doing good. So over to you to calculate them. There is only one equation that we have read, one equation for matter wave, one equation for photoelectric effect. All the questions are going to come from that equation only. On that note, I will terminate this class and I'll see you tomorrow with X-rays. Take care and God bless you all of you. Bye bye.